Hello everyone, welcome to Sangam tutorials, Gubbi online classes for SSLC and Cbse 10th standard classes for mathematics and science. So in the today's session we will be going with the derivation of mirror formula, which is very important, and application level of problems, numericals you are going to face on this. So this formula is very easy, and the derivation what I am going to do in this session is not for the examinations, but purely for your knowledge. So we all know that without knowledge, if you score a lot of marks, no use in that. So therefore, marks with knowledge is our motto. So therefore, concentrate on knowledge, and naturally marks will follow that. No doubt with that. So in today's session, we will be going with the mirror formula derivation. Along with that, some important terminologies connected to the mirror formula I am going to discuss at the end of the session. So before that, we have to recapitulate the things what we had done in the previous class. So in the previous class we had concentrated on Cartesian sign conventions for mirrors. So yesterday a student called me over phone, sir, and he asked me, sir, why this is called as Cartesian sign convention? So why not only sign conventions, why it is called as Cartesian sign convention? That was a very nice question. I told him we will wait for the next session. In the next session itself I will discuss, so that all the students can know the real meaning of Cartesian sign conventions. Right. So it's very simple. We know that in your coordinate geometry you have studied regarding the Cartesian plane. It is a Cartesian plane. So we can divide the entire plane into four parts by drawing two lines. One is vertical, another is horizontal. So here usually we call this, that is the vertical line as the y-axis. This is taken as y and y dash, and the horizontal line is taken as x dash and x. And this point will be called as the origin, represented by O. Okay. So here in a Cartesian plane or in a rectangular coordinate system, we will be having a plane. On that plane we will have to identify a point. So to identify a point on a plane, we take the help of the rectangular coordinate system or the Cartesian system. So this is the Cartesian system here. So here this part, that is from the origin towards x, this is called the positive part of x-axis. You know that. So it is from here to here it is positive. This is the positive part of x-axis, and this will become the negative part of x-axis, and this will become the positive part of y-axis, and this is the negative part of y-axis. So here at the point of origin in this Cartesian system, if you consider a concave mirror like this, concave mirror, let the pole of the concave mirror be at the origin of the that is Cartesian system. So here if you take it as a concave mirror, take this as a concave mirror, and if you keep an object here at this point, take it as some AB or something. So AB is the object which is placed above the principal axis. So this x-axis entirely, the x-axis is going to become the principal axis, and above the principal axis we have kept the object here. So therefore the height or the size of the object is taken as positive, because the object is kept at the positive part of x-axis. So as it is kept at the positive part of the x-axis, that is in the negative part, in the negative part of the x-axis. So anything above the principal axis is taken as positive. So anything below the x-axis, that is the principal axis, is taken as negative. So here when we measure the distance of the object from the origin, here we measure in this direction. So this part of the line is the negative part of x-axis. Therefore this value what we take is negative. But actually what we discussed in the previous session is that when the light rays are coming in this direction, as you are measuring this object in the direction opposite to that of the incident light rays, therefore we take it as negative. So it is one and the same. You can understand in either of the ways, both are right, both are correct. So if this measurement, that is the distance of the object from the mirror, is measured in the direction that is opposite to the direction of the incident light rays, then it is taken as negative, what I had discussed with you. But Apart from that, this is also true, this is 100% true. So here the object is kept on the negative part of the x-axis. So therefore the distance measured from this origin, that is the pole of the mirror, to this object is taken as negative because this part of the x-axis is negative. So for example, if you get an image here, that is A dash, B dash image here. So here the image is also measured from the pole of the mirror, that is the origin of this Cartesian system. So this measurement will also be negative. So therefore it is taken as the Cartesian sign convection. That's called as Cartesian sign convection. For example, if you place the object somewhere here between the F and P, between F and P, if you place it, you get the that is image here at this point. In case of a concave mirror, that is the sixth ray diagram, last ray diagram. So here, this is the positive part of x-axis, and when you measure the distance of the image from the pole of the mirror, this is taken as positive. This is taken as positive. This distance is taken as positive because you are measuring from the origin towards the towards the positive part of x-axis, towards the image. So as you are measuring this distance in the same direction of the incident light rays, therefore this is taken as positive, what I had discussed with you. Along with that, as you are doing this measurement on the positive part of x-axis, therefore this measurement will be positive. This is according to Cartesian sign convention. Both are one and the same. The channel of understanding is different one. You go to the same concept, but the channeling is different. Two channels, right? So when you come to this, that is the height of the object. When you come to the height of the object, so it is nothing but it corresponds to the y-axis. So y-axis, it is the positive part of y-axis here. So this length, this height of the image, that is object, is equal to this length. Therefore, the height of the object is always taken as positive because this length is equal to this length on the positive part of y-axis. Therefore, this height is corresponding to this length on the y-axis. Therefore, the height of the object is taken as positive. So what we discussed is anything what you measure above the principal axis is positive. So both are one and the same here. So when you measure the height of this object or size of this object, so here it is correspondingly to this height on the negative part of y-axis. So therefore this height is taken as negative because this height is equal to this length on the negative part of y-axis. So this is according to Cartesian sign convention. But what we had discussed is, as this length is measured below the principal axis, therefore this length is taken as negative. See, this is the sign conventions, Cartesian sign convention. So we take the rectangular coordinate system or the Cartesian system to give a sign convention for the distance of the object from the mirror, distance of the image from the mirror, the height of the object and the height of the image. So this is nothing but the Cartesian sign convention. So what I had discussed is also true. What here it is also true. Just we reach to the same concept through different channels. This is the thing. I hope you got the answer. It was a nice question. Very good. Now, let us go to the next concept. So in today's concept, I am going to derive a formula that is which gives a relationship between the distance of the object from the mirror, the distance of the image from the mirror, that is the distance of the object from the mirror is indicated by u, the distance of the image from the mirror is indicated by the letter v. So according to the sign conventions what you have discussed, and the focal length, the distance between the pole and the point where all the light rays after reflection meet at a point is called the principal focus. So the distance between principal focus and the pole of the mirror is called as that is focus, that is focal length. So u, v and f, we have three elements here. One is the object distance, another is the image distance, another is the focal length. So object distance is indicated by u, image distance is indicated by v, and the focal length is indicated by f. So what is mirror formula? Mirror formula is a formula which gives you the relationship between these three elements, that is which gives the relationship between the distance of the object from the mirror, the distance of the image from the mirror, and the focal length of the mirror. So the relation which is in between these three elements is called as the mirror formula. So mirror formula is a universal formula. This formula gets applied for both type of mirrors, that is concave mirrors as well as convex mirrors. So one point to be noted here is the aperture of these mirrors. We consider the aperture of these mirrors is very small, because we are not dealing with very big mirrors. We only consider only very small mirrors where we use in our physics lab. So according to that, mirrors formula is applicable to those particular mirrors which are having very small apertures. So what is mirror formula? Mirror formula is a relation between the distance of the object from the mirror, the distance of the image from the mirror, and the focal length of the mirror, that is between u, v and f. So the relation comes like this: 1 by f is equal to 1 by u plus 1 by v. That's the formula there. So usually what teachers do is, this is the mirror formula, you had this. So wherever you get this, you have to apply. So let us know how it comes, let us derive how it comes. So before I go to the derivation, the most important thing here is we have to learn a very simple basic concept related to mathematics, that is similar triangles. So if you are good in that concept, that is AA criterion or AA similarity criterion, if you are good in that, you can easily understand the derivation of mirror formula. So let's learn how it comes. Somebody has done it, we are applying that in our daily life. That's not a very big criteria for a student. So a student has to go to the origin, how it comes, how it is made, so how it is derived. So if it is in your limits, no wrong in learning that. So many teachers feel that it's not in the syllabus, no need to learn all these derivations. But if you learn the derivation, you get the depth of the knowledge and you can enjoy the concept of light. Okay, so let us go to the basic concept which is required for the derivation of mirror formula. Very simple derivation, right? So let us go with the basic. So consider two triangles. I will take it as triangle ABC, and another triangle I will take another triangle, that is I will take triangle PQR. So there are two triangles here. So these two triangles are not same. They are not same. They appear to be similar. They are similar. They are not same. So in your previous classes you have come across congruent triangles. So those geometrical figures which have the same shape and same size are called as congruent figures. You have learned in your 8th standard classes and also in your 9th standard classes. All the postulates related to the congruency were repeated in 9th. So anyway, so these are not congruent. I am very sure about it. So if they are not congruent, then what they are? They are similar. They look similar. So what makes them look similar? They have the same shape, no doubt in that. They have the same shape, but their size varies. Their size varies. This appears small in size and this appears big in size, but they have the same shape. That's very important. So if two geometrical figures are having the same shape but different sizes, they are similar figures. They are similar figures provided on two conditions. So let us see what are those conditions here. So now, in triangle ABC, let us assume that this angle A is equal to angle B. So in triangle ABC and triangle PQR, angle A is equal to angle B. So I am telling you this, so therefore it's according to data. So let us take angle B is equal to angle Q. So angle B is equal to angle Q, or else angle ABC is equal to angle PQR, or it can it's your convenience. So in two triangles, if two pairs of corresponding angles are equal, then the third angle will be compulsory equal. So that is the third angle, that is angle C, and angle R will be compulsory, they will be equal, because in this triangle, this angle is equal to this angle is equal to this angle. Therefore, this angle should be equal to this, right? So in order to prove that these two triangles are equiangular, it's enough to show that their two pairs of corresponding angles are equal. It's enough. No need of showing that third pair of corresponding angles are also equal. No need. Just we have to show that two pairs of corresponding angles are equal. So this is the first pair and this is the second pair of angles. So angle A is equal to angle P and angle B is equal to angle Q. So therefore triangle ABC is similar to triangle PQR. So here this method of proving two triangles similar based on two angles is called as, it's a criterion, that is AA criterion. This is called as AA criterion, AA similarity criterion. So according to AA similarity criterion, these two triangles have become similar. So why they have the same shape? Why these two triangles are having the same shape? Because their corresponding angles are equal. If two geometrical figures have their corresponding angles equal, then we say that they will be having the same shape. Okay. Next, we will go with the corresponding sides. For example, how to identify the corresponding sides. So you have done it in your level classes. Once again, I will teach you. So in this triangle ABC, this is single mark. That is single mark given for angle A. So the side opposite to single mark is BC. So I will take BC. Now in this triangle ABC, single mark is angle A and triangle PQR, single mark is angle P. And in the sense, angle A and angle P are corresponding angles. So therefore, the side opposite to angle P is QR. So therefore, BC and QR are corresponding sides. They are corresponding sides. So the sides opposite to equal angles, they are equal angles. Both are equal angles. So the sides which are opposite to the equal angles, that is opposite to equal angles, they are equal angles here. Therefore, they are corresponding sides. Now you can identify the second pair of corresponding sides. Angle B is equal to angle Q. Therefore, the side opposite to angle B is AC and the side opposite to angle Q is PR. So therefore, AC and PR are corresponding sides. This is how it comes. Now you can easily identify the third corresponding side. So this is the third angle, this is the third angle, and they are equal. So opposite to this third angle is AB. So AB is corresponding side to PQ, that is third angle opposite, that is PQ. So AB corresponding side is for side AB, corresponding side in triangle PQR is PQ, for BC it is QR, for AC it is PR. So when these two triangles become similar, by a criterion that is called as AA criterion, then these are the corresponding sides. And these corresponding sides, in between the corresponding sides, when you take the ratios, those ratios will become equal. In the sense, if two ratios are equal, then the terms involved in both the ratio, that is, if A is to B is equal to C is to D, then A, B, C, D are in proportion. So, for example, if you take 2 centimeters and if you take it as 4 centimeters, the ratio between AB and PQ is 2 is to 4, that is 1 is to 2. So in the same ratio, you will get AC and PR. For example, I am writing this 3 centimeters and 6 centimeters. This is 4 centimeters and 8 centimeters. When you check this, 2 is to 4 is 1 is to 2. 3 is to 6 is again 1 is to 2. 4 is to 8 is again 1 is to 2. So if two triangles, when they become similar, then the corresponding sides will be in the same ratio. In the sense that the corresponding sides are proportional. So this is what we call the similarity criterion for two triangles. That is particularly A similarity criterion. So if two angles of one triangle are correspondingly equal to two angles of the other triangle, then both the triangles are similar. That is, once again, if two angles of one triangle are correspondingly equal to the two angles of the other triangle, then we say that the two triangles are equiangular. Okay, they are equiangular. If two triangles are equiangular, then they will be 100%, they will be similar. If two triangles are similar, we can announce that their corresponding sides are proportional. In the sense, their corresponding sides will be in the same ratio. So we can write the ratios. So AB by PQ will be equal to BC by QR, BC by QR, which is equal to AC by PR. So this is the statement which tells that the corresponding sides are in the same ratio. So this is nothing but AB is to PQ ratio is equal to BC is to QR ratio is equal to AC is to PR ratio. So this is the corresponding sides are proportional. So this is called A criterion. So if two angles of one triangle are correspondingly equal to the two angles of another triangle, then both the triangles are equiangular. If two triangles, next statement, if two triangles are equiangular, then they are similar. Next statement, if two triangles are similar, then their corresponding sides are proportional. So these are the three statements you have to remember. I hope you understood this. It's very easy. So these two triangles are similar, therefore their corresponding sides are proportional. So these two statements, if you remember, it's more than enough. If two triangles are equiangular, then their corresponding sides are proportional. So in the coming mathematics chapter, that is called similar triangles, we are going to derive this statement, this enunciation in the form of a theorem. So logically I will prove it and present it in front of you, right? So once again, if two triangles are similar, then their corresponding sides are proportional. So if you open the statement, corresponding sides are proportional, it's nothing but the ratio between their corresponding sides are equal. That is, this is to this, what the ratio you get, this is to this, what the ratio you get, and this is to this, what the ratio you get, will be same. So you can, with an example I have shown you here, 1 is to 2, 1 is to 2, and 1 is to 2. So this is the basic required for understanding the derivation of mirror formula, right? Okay, we'll go further. Now, so as the mirror formula is applicable for both concave mirrors and concave mirrors, concave and convex mirrors both. So I will take the help of concave mirror itself. Right? We will go with a concave mirror. I will take a little bit bigger one so that you can easily understand. This is the pole of the mirror. So this is outer surface is we know that it is silvered. So that inner surface is highly reflecting. So this is the principal focus. Let this be the center of curvature. I will draw a line joining all the 3 points. So that becomes the principal axis. Right? Everything is fine. Okay. So this is the center of curvature. This is the principal focus. We have to be a good observer now, because new points, very simple points I am going to discuss now by showing everything here. So you have to observe very well. So if you observe, you will get it. So this is center of curvature, right? So now let us place the object beyond the center of curvature. So when you place the object beyond the center of curvature, beyond the C, we know that according to the second ray diagram, the image will be formed between that is C and F. Image will be formed here between C and F. Okay, let us take the image to be formed. Okay, let us take one light ray from here, right, which is parallel to the principal axis. So it passes through the focus. The light ray is going to pass through the focus, goes out after reflection. So the second ray, let us make it to pass through the principal focus itself. Second light ray, let us pass through the principal focus. So according to rule 2, if a light ray directly passes through the principal focus of the mirror after reflection, it travels parallel to the principal axis. So after reflection, it travels parallel to the principal axis. So this is the light ray here. So this is the point where the two real light rays are meeting each other. So if two real light rays actually meet in front of the mirror after reflection, we say that at that point the image is formed, and that image will be a real image, and a real image is always inverted. Okay, let us draw the image here. So this is the image, right? This is I will call it as A dash, and I will call it as B dash. This is the image. Now 50% work is over, so remaining 50% is very important. Now let us draw the rays. Okay, now very important, please follow this, very important. So here we assume that the object is on the above the principal axis and perpendicular to the principal axis. So here also the image what it is formed here is below the principal axis and perpendicular to the principal axis, right? Okay, let us, I will call it as point M, and I will call it as point N for our reference, right? So this is the principal focus, right? So now let us call the height of the object, as we have discussed in the previous session, has h, small letter h. Let the height or size of the image be h dash. Let us represent this by h dash. Right? I hope the very good clearance is there. I hope you can easily see. Right? So this is h and this is h dash. This is A dash and this is B dash. Don't get confused. Right? So now from here, that is pole of the mirror to the principal focus. The distance here, this distance is called as the represented by f, that is focal length. So this is the focal length, that is f. Now here the mirror what I have taken here is a very small mirror with a very small aperture. That means small mirror means it's having very less aperture. So here, as the aperture of the mirror is said to be very small, the point M coincides with point P. So therefore I will draw a line here. So this is perpendicular to the principal axis. It's perpendicular to the principal axis here. So I can take this point P as this point P itself. This becomes point P. So here also, here this point N coincides with point P because the aperture of the mirror what we have taken is very small. So therefore I will draw a perpendicular line from here. So I will draw this. So here N and P coincide. So this is point P itself. Point P is this point P now. Okay, now. So here the distance from the pole, this is the pole of the mirror now. So pole of the mirror and point M as they coincide. So this is the pole of the mirror, we can consider this. So the distance between the pole of the mirror and the object is the object distance, and that is indicated by the small letter u. So this is u, right? The image is formed here. So here this point N coincides with point P, so nothing but point P is we can consider here itself. So therefore the distance between the pole of the mirror and the image, so P B dash is nothing but N A dash. Both are same because both the light rays are parallel, that is both the lines are parallel to each other here. So therefore I will take this as the image distance, that is as V. This is the length V. Now how to calculate this distance, that is B dash F, or how to calculate this BF. I hope you can see this. What is the length of BF? So here entire length is BP and this FP is F, that is focal length. Then what is this entire BP is the length that is called U, represented by U, that is the object distance. This entire length is object distance and this length is the focal length, and what will be this means it will be U minus F. When you take out this from U, if you take out this F from here, the remaining is U minus F. So BF length will be U minus F. So this will be the length of BF. Okay, very simple. Now let us take this length, this one, that is B dash F. So here this B dash P is nothing but V, that is the image distance, and this is focal length. So if you want this length, from this length you have to subtract this length. So that is, this entire length is V and this length is F. So this length will be V minus F. This length. So V minus F. This length. So this is the length of this one. That is B dash F. So now this is F here, no problem. So this is AB. So this H length will be equal to MP. This is H here. This is H. So this length is H dash. So this length is equal to this length here. So we can take it as H dash. So now, using all these things what I have written on the board, we will consider two triangles now. Right? One is this one, another is this one. So we will take this triangle which is here, this triangle and this triangle. So I will name the triangle now. Right. So in triangle ABF, this triangle, and triangle FNP, this triangle. In triangle ABF and triangle FNP, we will consider both these triangles. Right. So we will go with the derivation now. So in triangle ABF and triangle FNP in both the triangles, right? In both the triangles, angle ABF, this one is equal to angle FPN, because this line is drawn perpendicular to the principal axis. So angle ABF is equal to angle FN, that is FPN. Angle, I will show you once again, angle ABF is equal to angle FPN. So both are 90 degrees. Okay. Now this is one of the line tray. This is one of the line tray. So here both. Okay, right. Let me take this. This is one of the line tray, and okay, this is principal axis is one of the straight line. Okay, this is one of the straight line. This is one of the straight line. So these two angles, they become equal because they are vertically opposite angles. So according to the previous definition in your classes, so if two straight lines intersect at a point, then the vertically opposite angles are equal. So if you consider this as a line, and if you consider this as a straight line, that is principal axis as another line, then these two angles will be vertically opposite angles. So I will read the angles now. Angle AFB is equal to angle PFN. So this is vertically opposite angles. Okay. So in these two triangles, two pairs of corresponding angles have become equal. So in any two triangles, if two pairs of corresponding angles are equal, then we say that both the triangles are equiangular. Hence, if two triangles are equiangular, they are similar. So according to AA criterion, angle criterion, triangle ABF is similar to triangle FNP. That is according to AA criterion. According to AA criterion, both the triangles are similar. So now, if two triangles are similar, just now in the that is regarding similar triangles I discussed, if two triangles are similar, then their corresponding sides are proportional. So now we identify the corresponding sides. So now, one we will take opposite to that of the vertically opposite angle. So here, in this triangle, two angles have been considered here, this angle, and this becomes the third angle. So in this triangle, 90 degrees and this angle are considered, so this becomes the third angle. So now we will consider the sides which are opposite to the vertically opposite angles and the third angles. Okay. So now in the bigger triangle, first we will consider vertically opposite angle is this. Opposite to this side is opposite to this angle is AB. So I will write AB by. In this triangle, the side opposite to vertically opposite angle is PN. That is AB by PN. That's the ratio. Now we will go with the third angle here. In triangle ABF, this is the third angle. Third angle opposite side is BF is equal to BF by. In this triangle, this is the third angle. So third angle opposite is, that is FP by FP. So reason is corresponding sides are proportional. Corresponding sides are proportional. Now we will write the actual values of AB, P and BF and FP. So let us see what is AB. AB is H. We will write this by PN, PN. So PN is nothing but H dash. I have written already here. H dash is equal to BF. BF. So entire BF is U minus F. So U minus F by FP. So FP. FP. FP is nothing but the focal length, that is by F. Take it as equation 1. So we have, our journey is 50% over. Next 50% is remaining. We will go with another two triangles like this. Now consider these two triangles now. We will consider these two triangles. This one and this one. We will consider these two triangles. This and this. Okay. In triangle B dash, A dash, B dash, F and MPF. So we will consider two triangles. In triangle B dash, A dash, F and triangle MPF. MPF. Right. Now in triangle A dash, B dash, F, angle A dash, B dash, F, that is this angle is 90 degrees, and in this triangle angle MPF is 90 degrees. So therefore angle A dash, B dash, F is equal to angle MPF, that is 90 degrees. MPF. So reason is 90 degrees. So we will consider another pair of angles. So now in these two triangles, this is one of the straight line, this is one of the straight line. So if two straight lines intersect at this point, then the vertically opposite angles are equal. So angle B dash, F, A dash and M, F, P are equal. Once again, angle B dash, F, A dash, this angle B dash, F, A dash is equal to angle, that is MFP. MFP. So that is vertically opposite angles. So in both the triangles, two pair of corresponding angles are equal. So hence they should be equiangular. Hence they should be similar. So therefore triangle B dash, A dash, F is similar to triangle MPF. So this is according to AA criterion. According to AA criterion, both the triangles are similar. So if two triangles are similar, then their corresponding sides should be proportional. So in order to write the proportionality, we have to consider the third angle here. So in triangle MPF and triangle A dash, B dash, F, both they have become similar. So therefore we can take the corresponding sides. So if two triangles are equiangular, then they are similar. If two triangles are similar, then their corresponding sides are proportional. So we can take the proportionality here. So we will start from this triangle. That is, we will take the side opposite to this vertically opposite. So for this angle, opposite is MP, and for this angle is the corresponding angle. So therefore opposite to this is A dash, B dash. So therefore MP opposite to this, and for this it is the corresponding angle and opposite to this. So MP by A dash, B dash. So MP by A dash, B dash is equal to, now we will take opposite to that of the third angle, that is this is the third angle, opposite to this is, So this is the third angle here. First we will take this triangle. So for the third angle opposite this is F, that is FP by, so for in this triangle third angle is this, so opposite to this is V minus F. So it's already ready here, that is B dash F. So we will substitute the values. So MP value is H, which is equal to this. So H by A dash B dash is H dash is equal to FP. So FP value is F by B dash F value is V minus F. Take it as equation 2. So when you compare these two equations, we have got H by H dash is equal to U minus F by F, and the same H by H dash is equal to F by V minus F. So here two things are equal to the same thing, that is this thing and this thing. Both are equal to the same thing. So therefore they should be equal to one another. That's an axiom. So from 1 and 2, U minus F by F is equal to F by V minus F. So two fractions are there in between equals. So we can go with cross multiplication. F into F is F square is equal to U minus F into V minus F. U minus F into V minus F. So F square is equal to U into V is UV, U into minus F is minus UF, minus F into V is minus VF, minus F into minus F is plus square. So here on both the sides we have F square, so we can cancel this F square and F square. So remaining is UV minus UF minus VF is equal to 0. So when the things gets cancelled, here we have the thing equal to 0. Now, so here actually this is the mirror formula, but not handy. That's not handy. We cannot handle this while solving numericals. So we will alter this and we will make this handy so that we can easily apply while doing the problems. So UV minus UF minus VF is equal to 0. This is what we have got. So divide by UVF on both sides. So this is you may feel it very peculiar. Why we have to divide that by UVF? I told you this is itself is the mirror formula, but to make it handy, usable while solving numericals, therefore we divide that by UVF. So that's not a problem in physics. So UV by UVF minus UF by UVF minus VF by UVF is equal to 0 by UVF. Okay, 0 by UVF is 0 itself, no problem. So UV and UV cancels, so you are left over with 1 by F minus, okay, UF and UF cancels, so you are left over with 1 by V minus, here VF and VF cancels, so you are left over with 1 by U is equal to 0. So now, keeping 1 by F as the subject, transpose these two terms to the RHS. So this becomes 1 by F is equal to minus 1 by U. After transposing, minus 1 by U after transposing become plus. So 1 by F is equal to 1 by U plus 1 by V. So this is how we get the mirror formula. So this is very important. So this is the most important derivation. You should be having the knowledge of this. So simply somebody has done it, we are taking that, we are applying somewhere. That's not the real education. The real education is understanding the depth of the knowledge and also concentrating on scoring marks. So both should go parallel to each other. Knowledge and marks should be parallel to each other. Okay, anyway, I hope you enjoyed the entire session. So in the next session, I will be going with linear magnification and linear magnification with concave mirrors. So those two, they are also two formulas. I will derive that, relate with this, and then we will go with the numericals. So I wish you Happy learning, stay home, stay safe, save lives. And humble request is that 10th June is the last date for payment of first installment fees. So please, I hope you will do your responsibility. Thank you.